Am I live? Am I live? Am I live? All right. Hey, people. Good evening, and welcome back again to your Unacademy NEET English channel. I believe all of you are doing great, having a good time. So, my dear students, quickly let me know in the chats if all of you can hear me, if I'm perfectly audible, visible to every one of you. Let me know quickly in the chats with some fire emojis. If all of you can hear me, if I am perfectly audible, visible to every one of you. Let me know quickly in the chats. Let me know quickly in the chats, my dear students. I think yes. All right. Perfect. So, my dear students, as you all must be knowing, today we are going to do the short 45 questions of your complete chemistry. And in your upcoming NEET 2026 examination, you can expect the questions of the similar type, similar level, directly or indirectly. Okay? So that is the main motive of creating this particular session. So here I am in front of you with these short 45 questions of your complete chemistry. Yeah? I would want you guys to share this particular video with everyone, whosoever you know. Let everyone get benefited out of these sessions, which I believe you do not want. Yeah? You want to keep the competition low? All right, people. So can you quickly let me know in the chats which part of the country you guys are watching me from? Quickly, people. Can you let me know which state you guys are watching me from? I just want to know that first. The duration of the session is going to be almost 1 hour because we just have to do some 45 questions. Let me know quickly in the chats which part of the country you guys are watching me from. I want the chats to move like crazy. So people are watching me from Kolkata, Andhra Pradesh, Tamil Nadu, AP, Uttar Pradesh, Tamil Nadu, Jharkhand, Punjab, Karnataka, Andhra, Kashmir, Himachal, Telangana. Okay, nice. Mumbai. Okay. Meghalaya. Bikaner, Hyderabad. Kashmir, Assam. All right. Amazing. I think students across the country have joined in. That's great. That's amazing, people. That's amazing. Yeah, that's great. Well, I'm right now live from Srinagar, Jammu and Kashmir. And students across the country are watching. That's amazing. That's great. It's a great feeling though. Yeah. So by the way, before starting this particular session, I hope you already know that tomorrow on this particular channel, okay, tomorrow on this particular channel at 10 a.m. It was supposed to be 9 a.m., but I'm changing the timing to 10 a.m. tomorrow. Tomorrow, 10 a.m., my dear students, this is the amazing session which I'm going to take. Complete class 11th chemistry. Let me show it to you first. This is the tomorrow session, complete class 11th chemistry. I'll be completing this particular session in almost 8 to 10 hours, right? With all the important concepts, all the PYQs, every single thing I'll be discussing in this particular session. So tomorrow, 10 a.m. in the morning, you guys are going to join me on this particular channel, okay? And the ones who have not smashed the like yet, I would want you guys to smash the like as well because the likes are 599. It has to be more than 700-800 before starting the session. Yeah, so you're supposed to do that. Okay, and do not forget to click on notify me so that you remain updated about this particular session as well. Okay, so my dear students, let's get going. Let's get started with the today's session. So let me know in the chats, are you all super ready, my dear students? Is everyone ready? Tell me quickly in the chats. Yes or no, everyone? And I hope you guys are ready with your pen and paper as well, because you are the ones who are going to solve these questions. Okay, so let me know quickly in the chats. Are you all super ready? Yes or no in the chats? All right, people. Amazing. One more thing. The handwritten PDF of this particular session and all the sessions which I take on this channel, I'll be sharing on my Telegram. The name of the Telegram channel is Wassim Bhat Chemistry Official. Wassim Bhat Chemistry Official is the name of the Telegram channel on which I will be sharing the handwritten PDF of the today's session as well as all the sessions which I'll be taking here on this particular channel. Okay? So if you are not the part of the Telegram channel yet, be the part of the Telegram channel as soon as possible. Okay? Perfectly. So without wasting a lot of time, let's get going. Let's get started with a simple question that is going to be the confidence booster for all of you. A simple question that is going to be the confidence booster for all of you, my dear students. And my dear students, this is the question on your screen. Look at the question carefully and tell me the answer of this particular question in the chats. Tell me the answer of this particular question in the chats. A simple question this is. A confidence booster, I would say. I would call it. Quickly. Quickly, people. Arrange the following elements in increasing order of their electronegativity. A simple basic question this is. Right? A simple basic question. And I believe all of you should be in a position to solve this at least, right? It does not need my help. It's a simple one. It's a simple one. Exactly. Majority of you are perfectly right. You know, fluorine is the most electronegative element, followed by oxygen, followed by nitrogen. So this is the only option which is satisfying it. So I am going with option number A. One simple question, confidence booster question, easy kill question, and almost like 5 to 6 questions in your chemistry. In the actual NEET paper, you'll get like this, easy kill questions. And you don't need to solve those questions. By just looking at those questions, you can do them. There'll be almost 5 to 6 questions like this. Okay, number 1. Moving on to the second question. Look at this particular question carefully, guys. The question is mass of magnesium required to produce 220 ml of hydrogen gas at STP on reaction with excess of dilute HCl. So basically, as far as this question is concerned, your magnesium is reacting with HCl. And you must be knowing when magnesium reacts with HCl, it leads to the formation of MgCl2, and with that you get H2 gas, right? So if I ask you, is the reaction balanced? No, the reaction is not balanced yet. So my dear students, make it 2 times. I believe now the reaction is balanced. As far as the question is concerned, we are supposed to produce 220 ml of hydrogen gas at STP. We are supposed to produce 220 ml of hydrogen gas at STP. And we are supposed to calculate what mass of magnesium is required to produce 220 ml of H2 gas at STP. That is the question. So first of all, if I ask you, how many moles of H2 am I supposed to produce? How many moles of H2 I'm supposed to liberate? It's going to be given volume of the gas. Given volume of the gas, how much is that? 220. Given volume of the gas in ml divided by 22400 ml. These are the moles of H2 which I'm supposed to produce. Correct? Right? Am I clear with this? Right, people? So how much this value comes out to be? Quickly in the chats. 220 divided by 22400. Approximate answer. I need approximate answer. I don't need exact answer. This volume was in ml, so I divide with 22400. If this volume was in liters, I was supposed to divide with 22.4 liters. So tell me, what is this value? It's going to be 0.01, right? Approximately. So these many moles of H2 I'm supposed to produce. Correct? Now look at the stoichiometry coefficient. Here it's 1, here it's 1. Can I say as per stoichiometry is concerned, 1 mole of H2 is produced from 1 mole of magnesium. Correct? If 1 mole of H2 is produced from 1 mole of magnesium, therefore 0.01 moles of H2 would be produced from 0.01 moles of magnesium. Right, people? So these are the moles of magnesium which are required to produce 220 ml of H2 gas. But am I supposed to calculate moles of magnesium? No. I'm supposed to calculate mass of magnesium. So mass of magnesium is simply going to be moles of magnesium multiplied by molar mass of magnesium, which is 24. Correct? I think you are done. I think you are done. Correct, people? Correct? Is it clear? Is it clear to everyone? Quickly in the chats. Quickly in the chats, people. So this is going to be 0.24 grams. This is going to be 0.24 grams. I know a lot of students will answer this, but my dear students, you have to look at the units. This is 0.24 mg. Here I got the mass in grams, right? Perfect. 0.24 mg means if I multiplied this with 1000, it will be almost 240 mg. Now, which is the closest? 240 mg. So I'll go with option number 4. So option 4 is the correct answer of the question. Right? Perfect. Someone is saying, sir, please stop these videos by listening only, time waste. You can leave the channel if this is time waste for you, but for others, it's beneficial, okay? All right, people, moving on to the next question. Moving on to the next question. What do you think about this one? What do you think about this one? Quickly. Quickly, people. Everyone give it a try. You're given the reaction. The reaction is 2A gives B plus C. Equilibrium constant of this reaction is given. All right. At a given time, at some time t, the composition of the reaction mixture A is to B is equal to C is equal to 2 into 10 raised power minus 3 molar. So, at time t, the concentration of A, B as well as C. I would say concentration of A as well as concentration of B as well as concentration of C at some time t is given to me as how much? 2 into 10 raised power minus 3 molar. 2 into 10 raised power minus 3 molar. Now, my dear students, at time t, if I calculate reaction quotient is going to be concentration of B raised power stoichiometric coefficient, concentration of C raised power stoichiometric coefficient, concentration of A raised power stoichiometric coefficient, right? So what will be this value? This is 2 into 10 raised power minus 3. This is 2 into 10 raised power minus 3. This is 2 into 10 raised power minus 3 ka square. The value comes out to be 1, right? So look at the QC value. QC value is 1, right? What is the KC value? KC value is 4 into 10 raised power minus 3. So can I say QC is greater than KC? And you should be knowing when QC is greater than KC, which shift favors? Backward shift. Okay? So reaction has got the tendency to go in the backward direction. So it's option 3. That's going to be the correct answer of the question. When QC is greater than KC, reaction shifts backward. Reaction has got the tendency to go in the backward direction. Right? Moving on to the next question, people. Moving on to the next question. Tell me, what do you think about this one? Tell me, what do you think about this one? Quick, people, quick. Give it a try. Everyone. If you talk about NH3, right? My dear students, if I talk about NH3, nitrogen has got one lone pair. You know it already. The type of the molecule is AB3L1. AB3L1 means pyramidal, right? So NH3, you're matching with option A. It's pyramidal. Perfect. BRF5. Perfect. So there is one lone pair on bromine. The type of the molecule is AB5L1. So it is square pyramidal. So B, I'm matching with 4. Am I getting the answer from anywhere? A, you are matching with 1. B, you are matching with 4. A, you are matching with 1. B, you are matching with 4. Right? So I think you are done. What is the correct answer? It's option A. I'm not going to check the rest of the options. I believe this is clear to everyone. My dear students, moving on to the next question. What do you think about this one? Based on the data given below, the strongest reducing agent is. My dear students, the one that has got more reducing power is going to be the good reducing agent. And remember, reducing power is directly proportional to SOP, right? So I have to give the answer as per SOP values. Yeah? I need to give the answer as per SOP values. Now look at all these values which are given. If you look carefully, Cr2O7 di-negative. Here chromium is in +6 oxidation state. +6 to +3. Decrease means reduction. So this is SRP value. Okay, this is SRP value. This one, 0 to -1. This is Cl2 giving Cl negative. 0 to -1, decrease. So this again SRP. Right? +7 to +2, decrease in the oxidation state. Again SRP. This is also +3 to 0, decrease in the oxidation state. This is SRP. I need to give the answer as per SOP. I need to give the answer as per SOP. So I'm going to reverse their signs. So when you reverse the sign, it becomes minus 1.33. When you reverse the sign, it becomes minus 1.36. When you reverse the sign, it becomes minus 1.51. When you reverse the sign, it becomes plus 0.74. So now these are SOP values. So where do you find more SOP? I would say this SOP value is maximum because it's positive in sign. All the others are negative. This has got more SOP. More SOP means better reducing agent. So it's going to be chromium. That's going to be the better reducing agent among all. Clear, people? Everyone? Yes. Moving on to the next question. Moving on to the next question. The highest number of helium atoms is present in. Highest number of helium atoms. So here, you have got 4 moles of helium. So it's going to be 4 Na atoms of helium. It means 4 Na atoms of helium. 4U of helium. 4U. 4U. What is the mass of 1 atom of helium? Mass of 1 atom of helium is 4U. 4 AMU. Right? So 4U means 1 atom of helium. Perfect. 4 grams. 4 grams is the molar mass of helium. Right? So that means we have got 1 mole of helium. 1 mole helium means we have got Na atoms of helium. Na atoms of helium. Here we are given with volume. Right? We are given with volume in liters at STP. So I'll calculate moles. Moles are going to be given volume divided by 22.7 I'll use here. Perfect. As per the new convention. So this value will be how much? I think you can easily solve it now. Right? Perfect. So it will be 0.1 moles. Now moles multiplied by Avogadro's number. So it's going to be 0.1 Ne. So in the last option, you have got 0.1 Ne. So where are the maximum number of atoms? So it's option 1. That's the correct one among all. Again, an easy question, which I believe you can easily solve. So tell me in the chats, what do you think about this one? Isothermal. What happens in isothermal process? Temperature remains constant, right? Isothermal process carried out at constant temperature. Isochoric process, volume constant, right? This is again an easy question. Isobaric process, constant pressure. Adiabatic process, no heat exchange between system and surroundings. Now you can match them and you are done. The functional group that shows negative, then functional group that shows minus resonance effect. So which one shows minus M? Which one shows minus M? Quickly. These are the exact question I got in the mock test today. That's great. I don't know which mock test you are following. Which one shows minus M? It's pretty much evident. It's carboxylic acid, COH group, right? Perfect, guys. Perfect. Amazing. Tell me the answer of this particular question. The question is from the chapter Atomic Structure. My brother wants to join NEET 2027 batch. Just wait for it after the NEET 2026 examination gets over, right? Right after that, I'll be starting a batch for 2027. Just wait for that. I'll tell you which batch to join. Just wait. Quickly, guys. The energy of the electron in the ground state of He positive. So we are given with He positive ion. And they are talking about its ground state. That means N1 is equal to 1. Ground state. What is the atomic number of helium? Hydrogen, helium. Atomic number is 2. The energy of the electron in the ground state of this. So E1 value is equal to minus x joules. Perfect. Now, N is equal to 2 state of Be tripositive. So you are given with Be tripositive as well. And shell number of it is given as 2. Its atomic number, hydrogen, helium, lithium, beryllium. So it's 4. Perfect. So its energy E2 we have to calculate. Perfect. My dear students, you know the formula. Energy of the nth Bohr's orbit is directly proportional to Z square, inversely proportional to N square. Right? So can I use the formula E1 divided by E2? Simple. E1 divided by E2 is equal to, it is going to be Z1 square divided by Z2 square multiplied by N2 square divided by N1 square. Right? So what is Z1 square? 2 ka square is 4 divided by Z2 square. 4 ka square is 16. N2 square. 2 ka square is 4. N1 square, that is 1. Perfect. So it is 4 4s are 16. 16 by 16 is 1. So it's 1 by 1 basically. Now what is E1 value? E1 value is given to me as minus x. So minus x divided by E2 is equal to 1 divided by 1. So I got to know E2 is equal to minus x joules. Right? Is there any option like that? Option 1. Simple. Absolutely, guys. Perfectly done. Perfectly done. Moving on to the next question. Moving on to the next question. Look at the options and solve it. Look at the options and solve it. Look at the options and solve it, people. We have to give the order for bond angle, right? Order for bond angle. Check it. Check it quickly, people. We have to give the order for bond angle. Check it quickly. Let me know in the chats, people. Let me know in the chats. What do you think? This is BF3, right? BF3 is planar. It is planar, 120 degree, right? It is planar, 120 degree. There is no, similarly, CLF3. CLF3 is T-shaped, 90 degree. It is 90 degree. Correct, people? So what should be the order? I'll go with option A directly. Right? Right? And PF3, you know, its bond angle will be almost. So see, first of all, PF3. If you remember, this is NH3. After NH3 comes PH3. In case of NH3, the bond angle is 107 degree. I hope you know. Right? And here it will be lesser than that. It will be approximately in 90s. It will be approximately in 90s, basically. It will be approximately 90s. So I'll go with directly option number 1. Tell me the answer of this particular question. Tell me the answer of this particular question. What is the IUPAC name of this? Quickly. So start the numbering. Prioritize the functional groups. It is 1, this is 2, this will be 3, this is 4, this is 5, and this is 6. So it is first of all 3 bromo. It is 3 bromo. Then I'll be writing 2 hydroxy. 3 bromo, 2 hydroxy. Then I'll be writing 5 nitro. 5 nitro. Benzoic, 1 acid. Benzoic acid. Right? A lot of people are saying option 3. Talk about the alphabetical order, guys. This is H. This is H. This is B. B comes first, then comes H. B comes first, then comes H. So I have to write bromo first. So it's 3 bromo, 2 hydroxy, 5 nitrobenzoic acid. Right? You have to take care of the alphabetical order as well. Okay, moving on to the next one. A simple question. A simple question, people. Quick, everyone. SO2, NO2 negative, N3. First of all, N3 negative. It will be sp hybridized. It is linear. N3 negative. Now, for example, I'm talking about SO2. Sulfur is the central atom. How many valence electrons? 6. How many surrounding atoms? 2. So sigma bonds are 2. Right? How many lone pairs are on sulfur? 1. So 2 sigma, 1 lone pair. Steric number is 2 plus 1, 3. Hybridization is sp2. Right? Similarly, when you calculate its hybridization, this will be also sp2. So sp2, sp. It's option number 1. It's option number 1. Moving on to the next question. Look at this question. The volume of 0.02 molar HBr required to neutralize what? Barium hydroxide. So it is basically acid-base neutralization. Acid-base neutralization reaction. Acid-base neutralization. Look carefully. Molarity of HBr is given to me as 0.02. Right? Its volume I need to calculate. Molarity of barium hydroxide is given, I think. How much? 0.01. And its volume is given to me as 10 ml. Perfect. My dear students, what will be the N factor of HBr? It's a monobasic acid. Its N factor is 1. N factor of barium hydroxide, it will be 2. Now, you know, molarity multiplied by N factor, that gives me normality. So normality will be 0.02. Molarity multiplied by N factor, that gives me normality. So normality is again 0.02. So I'll use the simple concept of equivalence. I'll say milliequivalence of this reacted will be equal to milliequivalence of this. So I can say milliequivalence of first. That means N1V1 in ml will be equal to N2V2 in ml. And we are done. What is N1? 0.02. V1 to be calculated. N2 is 0.02. V2 is 10. Right? So this term cancels out. V1 value comes out to be 10 ml. So this is the volume of HBr which I was supposed to calculate. So I'll go with option number C. Simple, I use the equivalent concept, nothing else. Perfect. Moving on to the next question, my dear students. A simple question which all of you would be already knowing. The question is, select the compound from the following that will show intramolecular hydrogen bonding. Hydrogen bonding within the molecule. Hydrogen bonding within the molecule. Which one? Do you see this? Over here, there'll be hydrogen bonding. Hydrogen bonding within the molecule. So this is intramolecular. Perfect. This is within. Here it is intermolecular, intermolecular. This is the only one which shows intramolecular hydrogen bonding within the molecule. Okay, moving on to the next one. Look at this question. Look at this question, guys. A heat engine carries 1 mole of an ideal gas. So we have got 1 mole of ideal monoatomic gas. Okay, monoatomic gas. So how many moles? 1. If it is monoatomic, CV will be 3 by 2R. CP will be 5 by 2R. Okay. Undergoes the cycle as shown. We have to calculate QAB and QCA. This is QAB and QCA. If I talk about the process AB first of all, my dear students, during this process AB, what is remaining constant? Volume is remaining constant. So AB process is basically isochoric. It is isochoric. Volume is remaining constant. Perfect. So technically, I'm supposed to calculate QAB. QAB. So I'm supposed to calculate heat absorbed or released during the process AB. So can I say I'm supposed to calculate heat absorbed or released at constant volume? And you must be knowing heat absorbed or released at constant volume is nothing but delta U. And delta U for the ideal gas is NCV T2 minus T1. Right? N value is 1. CV 3 by 2R. T2 minus T1. A to B. This is T1, this is T2. T2 minus T1. So 600 minus 300. 600 minus 300 will be 300. Correct? So it is 900 divided by 2, which means 450 R. So QAB is equal to 450 R. QAB is equal to 450 R. Now, I have to talk about QCA. Now, if you look at the CA process, during the process C to A, what's happening? Pressure is remaining constant. Pressure remaining constant means isobaric. Isobaric. And remember, heat absorbed or released during process CA. That means we have to calculate heat absorbed or released at constant pressure. Right? And my dear students, you know, heat absorbed or released at constant pressure is nothing but delta H. And delta H for ideal gas is NCP T2 minus T1. Right? What is N value? That's 1. CP value, 5 by 2R. T2 minus T1. So I'm going from C to A. So this initial temperature, this is final. So final minus initial. So 300 minus 450. That comes out to be minus 150. So this will be 750 divided by 2. Minus 375 R. Minus 375 R. Which option is satisfying it? Minus 375 R. So I'll go with option C. Correct? I believe this is clear. I believe this is clear. Okay. Moving on to the next one. Tell me the answer of this one. Quick. Quickly, guys. The question is the correct decreasing order of spin magnetic moment. Spin magnetic moment. I think this is something which all of you can easily solve. Right? So you have to check the maximum number of unpaired electrons. First of all, if you talk about chromium, chromium configuration is 3d5 4s1. But we are given with somewhere I'm given with CR tri-positive. So CR tri-positive means take 3 electrons out, 1 from here, 2 from here. So it becomes 3d3 configuration. 3d3. So here we have got 3 unpaired electrons, right? Similarly, you have got chromium di-positive. Chromium di-positive. Perfect. So it will be having 3d4 configuration. 3d4 means 4 unpaired electrons. Perfect. Copper. Copper's configuration is 3d10 4s1. Now, they are mentioning Cu positive. So take 1 electron out. In Cu positive, if you take 1 electron out, there is no unpaired electron. There is no unpaired electron. Cu di-positive. Cu di-positive. 3d9 configuration. 3d9, there will be 1 unpaired electron. Now, more the unpaired electrons, more the magnetic moment. More the unpaired electrons, more the magnetic moment. Now you can choose the option. So Cr di-positive will be having maximum. Cr di-positive will be having maximum. Correct? Cr di-positive will be having maximum. So I'll go with option number 4. Right? Not option number 3. This is Cr di-positive maximum. Why you're saying 3? It's 4. Okay, moving on to the next one, people. What do you think about this one? We have to get the Kp by Kc value. I'm given with the reaction. Can you tell me what will be the delta Ng for the reaction? Delta Ng for this reaction will be number of moles of gaseous products, which is 1, minus number of moles of gaseous reactants, which is 1 plus 1 by 2, that's 3 by 2. So 1 minus 3 by 2 is nothing but minus 1 by 2. Now you know your Kp is equal to Kc RT raised par delta Ng, right? So we have to calculate Kp divided by Kc. Kp divided by Kc is equal to RT raised par minus 1 by 2. So you can say 1 divided by root of RT. Is there any option like that? Kp by Kc, 1 divided by root of RT. Yes? Perfectly done. Moving on to the next one. Tell me the answer of this question. The correct order of resonating structures. The correct order of resonating structures. Quick. It's a very simple one. Again, see, do you see charges on the atoms? Yes, I can see charge here on oxygen, charge here. I can see charge here, charge here. Over here, do you see any charge on any atom? No. There is no charge on any atom. So this will be the maximum stable one, right? So 3 is going to be maximum stable. And there is only one option that's satisfying that. Right? Only one option that's satisfying that. Chalo, tell me the answer of this one, because this is again the easy question. Quickly, guys. Do you see this C2 molecule? A famous molecule C2, its bond order is 2 and it has got both the bonds are pi bonds. Right? All the others you can easily check. All the others you can easily check. Right? This is ethane, ethene, ethyne. You know it. Look at this question. A first order reaction which is 30% complete in 30 minutes has the half-life of. First order reaction which is 30% completed in 30 minutes has the half-life of. First of all, time taken to complete 30% of the reaction is given to me as how much? It's given to me as 30 minutes. What do I need to calculate? I need to calculate half-life. For the first order reaction, half-life is nothing but 0.693 divided by K. How do you get the K? Do you know the formula? Time taken to complete X% of the reaction is equal to 2.303 divided by K. It is a log of 100 divided by 100 minus X. This formula is valid for the first order kinetics. Now take K here, will be equal to 2.303 divided by time taken to complete 30%. That is 30 minutes, log of 100 divided by 100 minus X. X is 30. So you can get the K value from here. 2.303 divided by 30. It is the log of 100 divided by what? 70. So log of 10 by 7. Log of 10 by 7, which will be log 10 minus log of 7. Perfect. You know log 10 is 1 and log 7 will be approximately 0.8. Now matter of calculation, you'll get the K value. Once you get the K value, put it here, get the half-life of the reaction. Simple. Right? Understood this question as well? By just using the formula and we are done. And final answer of the question you'll get is 58.2 minutes. 58.2 minutes will be the final answer of the question. Tell me the answer of this one. Tell me the answer of this one. An aqueous solution freezes at. So this is the freezing point of the solution. You know delta TF. Delta TF. Delta TF is basically freezing point of what? Delta TF. Depression in freezing point. Quick. Depression in freezing point. It is freezing point of solvent minus freezing point of solution. Right? That is delta TF. That's equal to Kf multiplied by M. Right? That's equal to Kf multiplied by M. So we have got aqueous solution. So this will be 0. Freezing point of solvent is 0. This value is given to me. How much? This is already minus. Minus becomes plus. It is plus 0.186 is equal to Kf value is 1.86. So from here I can calculate molarity. So molarity is equal to 0.186 divided by 1.86. Right? So this will be 0.1. I got the molarity of the solution. What do I have to calculate? Elevation in boiling point. I need to calculate delta TB. Delta TB is nothing but Kb multiplied by M. And Kb value should be given in the question. How much? Minus 0.512 and M is how much? M is 0.1. So this value will be 0.0512. I think this is plus. It's not minus, okay, in the question. So it is 0.0512. Is there any option like that? Yes, sorry, this one. Perfect. You have to remember few log values, right? Till log 10 you can remember, that's it. Tell me, in which of the following KP and KC are not equal? What is the relation between KP, KC? You know KP, KC is equal, KP is equal to KC, RT raised by delta N, correct? So my dear students, when delta Ng is 0, anything raised by 0 is 1, then KP, KC becomes equal. So if delta Ng is non-zero, your KP and KC won't be equal. I have to check in which of the following KP, KC won't be equal. So basically, I have to check that reaction whose delta Ng is non-zero. This is the reaction whose delta Ng is non-zero. If you calculate delta Ng for this reaction, it will be number of moles of gaseous products, 1 plus 1, 2, minus number of moles of gaseous reactant, that's 1. So delta Ng is non-zero. KP and KC won't be equal. Correctly done? Moving on to the next one, people. Look at this question. Look at this question. When 50 ml of 0.1 molar NH3 is mixed with 10 ml of HCl, so basically acid is going to react with base. What is the pH of the resulting solution? So you are making NH3 to react with what? To react with HCl. It is going to form your salt. Salt is NH4Cl. Correct? Now, if I ask you at time t is equal to 0, am I given with its molarity and volume? Yes, its molarity and volume is given. Now, molarity multiplied by volume in ml. Molarity multiplied by volume in ml. That gives me millimoles. So, millimoles of NH3 will be 5. This into this. Millimoles of HCl will be this into this. That will be 1. And in the beginning, this will be 0. Now, which one is limiting reagent? This one. So, I'll be left with nothing. 4 millimoles of NH3 will be left. 1 millimoles of salt will be formed. So, when the reaction would have stopped, in the container, I'll have weak base and I'll have salt of same weak base with the strong acid. Finally, when the reaction would have stopped, I'll be left with weak base and the salt of same weak base with a strong acid. So, I'm getting a basic buffer. Basic buffer. How do I calculate pOH of a basic buffer? Do you remember? It is pKb plus log of concentration of salt divided by concentration of base. You can say something like this. What is pKb value? pKb is given to me as 4.75 plus log of. What is the concentration of salt? Concentration of salt will be millimoles of salt divided by total volume. Total volume is 50 plus 10, that's 60, divided by concentration of base. That will be millimoles of base divided by total volume. So it will be 4 by 60. So 60 cancels out. So it is 4.75. This will be log of 1 by 4, which will be minus log 4 basically. Minus log 4. Log 4 is 0.6. So the value comes out to be 4.15. So, but this is pOH. What am I supposed to calculate? I'm supposed to calculate pH. You know, pH plus pOH is equal to 14. So I would say pH is equal to 14 minus 4.15. The answer will be 9 point something. Yes? Understood? A simple question, guys. Not difficult or something. I've solved many sort of these questions in the actual sessions. If you see the ionic equilibrium chapter, I have taken in detail on this particular channel. We have done that already. Yeah? I believe this sort of a question is clear. Hi Wassim sir, I was your student back in 2021, 2022. My name is Munib. My sister also studied from you. We both got our seats. I'm currently in SKIMS pre-final MBBS. Glad to know that. Congratulations. God bless you. Keep helping people. Keep doing great in life. Yeah? Chalo, moving on. Moving on to the next question, guys. Tell me the answer of this one. Order of, I think this question we already solved. It's a repeated question. Right? Electronegative. Okay, this is a repeated question. Sorry for this. Okay, the number of radial nodes. The number of radial nodes. The number of radial nodes. Quick. The number of radial nodes. How do you calculate the radial nodes? Radial nodes are also called as spherical nodes. Right? The formula is n minus L minus 1. N value is 3. What is the value of L for P? That's 1. So it's basically 3 minus 1 minus 1. So the value comes out to be simple. Yeah? Done? Perfect. Which among the following has the highest boiling point? Tell me in the chats. Highest boiling point. highest boiling point. This is CHO, right? This is simple. Your alcohol. This is ROR. Tell me. Tell me quick. It's a simple question, guys. I mean, this is something which every one of you should be doing, right? There will be intermolecular hydrogen bonding here, and because of intermolecular hydrogen bonding, its boiling point will be maximum among all, right? No need to think a lot. No need to think a lot. First ionization energy. Argon. Argon is group 18 element, right? Argon is your 18th group element. Sulfur. Sulfur is group 16. Perfect. We have got Se. Se comes down this. Then we have got barium. That's group 2nd. Calcium, right? Okay, leave them. They're having the least ionization energy. So first of all, argon will be having maximum ionization energy, right? Now down the group, ionization energy decreases. So argon will be having maximum, right? After that, I'll give priority to sulfur, then Se. Now, among barium and calcium, down the group, ionization energy decreases. So calcium comes first, then it's going to be barium. So which option is satisfying that? Check that and give the answer. People are saying option 1. So yes, option 1 is the correct one. That's great. Chalo. Tell me, what is this reaction called? CHCl3 with NaOH. Gives salicylaldehyde, a famous reaction. You know it. Few days back only KK sir was teaching this. What do you call this reaction as? Guys, this is something which everyone should know. It's your Reimer-Dimer reaction. Right? Can you tell me which one is the electrophile in Reimer-Dimer? What is our electrophile in Reimer-Dimer? What is our electrophile in Reimer-Dimer reaction? That is also asked. What is the electrophile in Reimer-Dimer? It's dichlorocarbene, yes? Perfect, great. Great, people. Chalo, I'm moving ahead. I am moving ahead. Look at this question carefully. In a first order reaction, so you have got a first order reaction like this. A gives B. Let's say at time t is equal to 0, the initial amount of reactant is A0, this is 0. Now, time taken for the decomposition of reactant to 1/4, to 1/4, to 1/4, and 1/8, and 1/8, and 1/8 of the initial concentrations are T1 and T2. So this I'm calling as T1, this I'm calling as T2. So basically, T1, what is this particular time? This is the time when 1/4 of reactant is left. And this T2, this is the time when 1/8 of the reactant is left, as per the question. Perfect. And the amount of reactant left is represented with AT. So how many conditions I got? I got 2 conditions. At time T1, the amount of reactant left is this much. At time T2, the amount of reactant left is this much. Now, what is our integrated rate equation? That is T is equal to 2.303 divided by K. It is a log of A0 divided by AT. Now, my dear students, if I put this condition here, instead of T, I'll write T1. So, T1 is equal to 2.303 divided by K. It is a log of A0 divided by AT. AT is A0 by 4. A0 cancel. 4 comes up. Log 4 is 0.6. Log 4 is 0.6. Calling this is equation number 1. Now, put this condition here in this equation. I'll write T2 is equal to 2.303 divided by K log of A0 divided by, what is AT? AT here is A0 by 8. So A0 not cancels out. 8 comes up. So 8 is 2 raised power 3. 8 is 2 raised power 3. 2 raised power 3 can be written as 3 log 2. 3 into log 2. 3 into log 2. 3 into log 2. Log 2 is 0.3. Perfect. So this value will come out to be 0.9. So this value will come out to be 0.9. Calling this is equation number 2. So if I divide the 2 equations, I need to get T1 by T2 value, right? T1 by T2. T1 by T2. This term cancels. 0.6 divided by 0.9. That's 6 by 9. 6 by 9 is 3, 2, 3, 3. So 2 by 3 is the final answer. Right? Perfect. A simple question. I mean, make 2 conditions, put them in integrated rate equation, and you're done. You're sorted. These sort of questions you should be in a position to solve, people. Okay, one simple question. Again, your confidence booster. The most stable carbocation. Which one is most stable? Tell me. Is anywhere carbocation getting stabilized by resonance or something? No. Right? I will just calculate the alpha hydrogens. I'll just calculate the alpha hydrogens. Where are the alpha hydrogens maximum? Look carefully. Here, 3 plus 2, 5, 5 plus 2, 7, 7 alpha hydrogens. So, more alpha hydrogens stabilizing this carbocation. Okay? Chalo, how do you solve this particular question? How do you solve this particular question? Density of 3 molar NaCl solution is 1.25. The molality is, there is one direct result between molality and molarity. Molality is equal to 1000 multiplied by molarity of the solution divided by 1000 multiplied by density of solution minus molarity multiplied by molar mass of solute. This is the formula. A direct result. A direct result, people. Molality is equal to 1000 multiplied by molarity divided by 1000 multiplied by density of solution minus molarity multiplied by molar mass of solute. Now molality will be equal to, put the values. Calculation I'm keeping up to you. You are going to do that on your own. Molarity is 3000 multiplied by, what is the density of solution? Density of solution is 1.25 grams per ml minus molarity is 3. Molar mass of solute. Solute is NaCl. NaCl's molar mass is 58.5. Do the calculation and you'll be getting the molality. And when you do the calculation, my dear students, the correct answer you'll be getting as 2.79. This is the molality of the solution. Perfect. Similarly, guys, moving on to the next one. Look at this one. From the solubility product. A simple question. You are given with zirconium phosphate, Zr3PO4. Right? This is your zirconium phosphate. Perfect. This is your zirconium phosphate. What I have to write? I have to calculate solubility in terms of Ksp. First of all, how will it undergo dissociation? This 4 will go here basically as the positive charge. This 3 will come here. So we have got 3 zirconium ions. So 3 times Zr plus 4 aqueous plus 4 times PO4 tri-negative aqueous. Correct? Let its solubility be S. This will be 3 times S. This will be 4 times S. Now what you have to write? You just have to write Ksp expression, which is going to be concentration of zirconium plus 4 raised power stoichiometric coefficient 3 multiplied by concentration of phosphate PO4 tri-negative raised power stoichiometric coefficient 4. So I'll say Ksp is equal to, this is 3s ka cube. This is concentration of PO4, that is 4s raised power 4, right? How much will be the value? Ksp will be, this will be s raised power 7 first of all. S raised power 4, s raised power 3, s raised power 7. Is there any option including 1 by 7, 1 by 7, 1 by 7? And 3 raised power 3 into 4 raised power 4. This will come out to be 6912. 6912. So I would say S will be equal to Ksp divided by 6912 whole raised power 1 by 7. So this is the final answer of the question. Yes? This sort of a question, again, you should be in a position to solve. The transition metal having highest third ionization energy. Third ionization energy. That means you are going to take the third electron out. That means you are going to take the third electron out. I believe it's going to be manganese only. What is the configuration of manganese? Manganese is basically 3d5 4s2. Now they are talking about the third ionization energy. So you have to take third electron out. So 2 are already taken out. So technically, we have to take electron out from this configuration. We have to take electron out from this configuration. So we have to take electron out from 3d5 configuration. 3d5, half filled, most stable, right? So to take electron out from here, maximum energy is required among all. So it's going to be manganese, whose third ionization energy will be maximum. Right, guys? Perfect. I believe this is clear. And if this is clear, I'm moving on to one more. I am moving on to one more. Tell me the answer of this question. Which of the following represents zero order? Zero order, zero order, zero order. Tell me. Zero order, quick. My dear students, if you remember, the integrate rate equation in zero order kinetics is AT is equal to A naught minus KT. Right? So if I plot a graph between concentration of reactant, that is AT versus T. AT versus T. AT you are plotting along y-axis. T you are plotting along x-axis. This is M. This is minus. This is C. Y is equal to minus MX plus C. Something like this. So concentration of reactant versus time for zero order is like this. So I'll go with option number 4. Okay? I'll go with option number 4. Got it? This is correct. Alright, moving on to one more. Tell me, this question is quick. Choose the correct option having all the elements with D10 configuration. D10, D10, D10. See, chromium is not D10, iron is not D10, nickel is not D10, cobalt is not D10, you know. Because this iron, 3D6 configuration, perfect. Cobalt is 3D7 configuration, iron, cobalt, nickel, 3D8 configuration. Chromium is 3D5, 4S1 configuration, so this cannot be. So, if here you have got nickel, so this cannot be. I have to check all the four, right? Here you have got copper, zinc. Copper is 3D10, 4S1, zinc is 3D10, 4S2. So, this can be. This cannot be. So if I see the options, it's option 3. That's suiting the best. Right? It's option C. Okay, I believe this is clear. And if this is clear, look at this question. The question is, you are given the reaction, delta H is given, delta S is given. All right. The reaction will become spontaneous above. Okay. For the reaction to be spontaneous, delta G system at constant pressure temperature should be negative. Now, delta G is nothing but delta H minus T delta S. So, this term should be negative. So, that means delta H should be less than T delta S. Or I can say T delta S should be greater than delta H. Or I can say T should be greater than delta H by delta S. Temperature should be greater than delta H by delta S. Right? Now, people, what is delta H? Delta H is given in kilo. Delta H is given in what? It is given in kilojoules. Okay? This is also given in kilojoules. So, 400 divided by 0.2. How much that will be? Quick. Delta H is 400 kilojoules. Delta S 0.2. So it will be 4000 by 2. Right? 4000 by 2 will come out to be how much? 2000. So temperature has to be greater than 2000 Kelvin. So temperature should be greater than 2000 Kelvin. Correct? Temperature should be greater than 2000 Kelvin. Then only the reaction will be spontaneous. Okay, one more thing I'll tell you. I told you temperature has to be greater than 2000 Kelvin. Then the reaction will be spontaneous. If temperature is less than 2000 Kelvin, the process will be non-spontaneous. If temperature is equal to 2000 Kelvin, system and surrounding will be at equilibrium. Anything can be asked here. Spontaneous, non-spontaneous, equilibrium condition. All right? I believe I'm clear with this. In O2 molecule, how many antibonding electrons are there? For that, you should know the molecular orbital configuration of O2. It will have, first of all, 6 antibonding electrons in total. And O2 molecular orbital configuration, in total, there are 16 electrons in O2. So, this is the molecular orbital configuration of O2. I believe you would be knowing this. Right? You just need to calculate the antibonding electrons, 2, 4, 5, and 6. Right? So, 6 antibonding. There are 2 unpaired molecular orbitals as well, due to which this is paramagnetic. Right? Due to which O2 is paramagnetic. Its bond order you can calculate, that's 2. Check this one, guys. The spin-only magnetic moment of FeCN6 trinegative. So iron here is in +3 oxidation state. So tell me one thing. Fe tri positive. Iron has got 3d6 4s2. When you take 3 electrons out, it is 3d5. It is 3d5 configuration. 3d5, 4 is 0, 4p0. Perfect. 4 is 0, 4p0. This is 3d5. Now tell me one thing. What is happening? What is happening? You've got cyanide here. Cn negative. Strong field ligand. It's going to cause the pairing. If it causes the pairing, 1 electron goes here, 1 electron goes here. So there'll be only 1 electron left. Only 1 electron unpaired. So how many unpaired electrons will be here? 1. So spin magnetic moment will be under root of n into n plus 2. Under root of n into n plus 2. So it's going to be root of 3. Root of 3 is 1.7. That's correct. That's correct. FeH2O6. It's a weak field ligand. Right? It's not going to cause the pairing. It's not going to cause the pairing. There'll be 5 unpaired electrons. So under root of 5 into 5 plus 2. This one is also correct. So assertion is correct. In both the complexes, iron is present in +3. Yes, iron is present in +3, but reason is not the correct explanation of assertion. Both are true, but reason is not the correct explanation of assertion. Yeah? Both are true, but reason is not the correct explanation of assertion. Tell me the answer of this one. Correct order of stability of carbanions. Correct order of stability of carbanions. Is this clear to everyone? Tomorrow's lecture will be very detailed. Don't worry. That too from basics. That too, I'll be trying to cover that entire session in almost 8 hours. How many log values we need to know? From log 1 to log 7 you need to know. Okay. So my dear students, if you look carefully, 2 and 2, 4. 4 pi electrons, that means this is anti-aromatic. So this has to be least stable. This has to be least stable. This is sp3 non-planar, so this is non-aromatic. sp3 non-planar, non-aromatic. 2 4 6 pi electrons following Huckel's rule. This is aromatic. Aromatic means maximum stable. So D is maximum stable, A is least stable. D is maximum stable, A is least stable. So option 2. D is maximum stable, A is least stable. Option 2. Okay, tell me this one. It's important, guys. Let me see how much you remember. This is cobalt herein plus 3 oxidation state. Cobalt herein plus 3 oxidation state. My dear students, iron cobalt 3d7 4s2. 3d7 4s2, right? 3d7 4s2. But this is cobalt tripositive. Take 3 electrons out. It becomes 3d6. It becomes 3d6, 4s0, 4p0, 4d0. Right? So this is 3d6. 1, 2, 3, 4, 5, 6. 4 is having 0, 4p having 0, and 4d also having 0. 4d having 0. Now, you can see H2O. H2O is normally a weak field ligand. H2O is normally a weak field ligand. But, when H2O is attached to CO tripositive, when H2O is attached to what? Normally, it's a weak field ligand. But when H2 is attached to CO tripositive, at that point of time, it acts like a strong field ligand. Remember it. It acts like a strong field ligand. And if it acts as a strong field ligand, pairing is going to happen. One will enter here, one will enter here. There will be no unpaired electron. If there is no unpaired electron, no magnetic moment. The number of unpaired d electrons, 0. For CO tripositive, it behaves like a strong field ligand. Perfectly done. Moving on to one more. Tell me the answer of this question. 3 moles of an ideal gas are compressed isothermally from 6 liter to 20 liter using constant pressure of 5 atm. Heat exchange Q. In case of isothermal process, whenever the ideal gas undergoes isothermal process, delta U is 0. That means Q is equal to minus W. Q is equal to minus W. We have to calculate Q. So technically we have to calculate W. How do I calculate W? External pressure is constant. So if the process is irreversible, it's minus P external delta V, right? So minus P external is how much? 5 atm. Delta V, change in volume, final minus initial. 20 minus 60 is minus 40. The value comes out to be how much? 200 atm liter. 200 atm liter. Do I need to calculate the answer in atm liter? Yes, this atm liter. If they ask you in joules, then you know 1 atm liter is nothing but 101.3 joules. Right? So this is basically W. This is basically W. If you got W, so Q is equal to minus W. It has to be minus 200 joules. Right? Perfect. So heat exchange. Q is equal to minus W. So they have already given only given the magnitudes here. So I'll go with option number C. Okay, one last question of the session, guys. I want you to tell me the answer of this question. And the PDF of this session I'll be sharing on my Telegram, which is Wassim Bhat Chemistry Official. This is the name of the Telegram channel on which I shall be sharing the PDF of the today's session as well. So tell me, sir, tell me tomorrow's session. Tomorrow we'll start the session at 10 a.m. 10 a.m. Okay? I'll be completing your complete class 11th chemistry. Okay, in detail. The most important concepts of every chapter with all the PYQs, all the concepts. So I would want every one of you to join tomorrow exactly at 10 a.m. sharp. Sir, this question came in Akash test. So what can I do about that? Guys, you know, your Henry's constant is inversely proportional to what? Solubility, right? The more the Henry's constant, lesser the solubility. Which one has got more Henry's constant? This is maximum. So A has got maximum. So A will be having least solubility. So I'll go with option number 4. There is only one option satisfying that. Okay? Now you must be thinking why I came up with only physical and inorganic and few organic questions. Organic short questions already KK sir has taken on the channel. Do watch that. Organic session already KK sir has taken. The short session. Do watch that for organic. This was for physical and inorganic. Okay? Sir, for some questions, Tuka's strategy is not working. It won't work for all the questions. I told you, first in the actual question paper, you have to do all the questions which you know. The remaining questions, it will be there at the end in last 10 to 15 minutes. right? Then you can use those simple strategies to guess the options, not the entire thing. Okay. Salt analysis. I'll be posting one small video on Sunday. Complete salt analysis in just 10 minutes. Okay. And entire salt analysis will be there in 10 minutes. I'll be posting that on coming Sunday, day after tomorrow. So I'll see you tomorrow exactly at 10 a.m. You guys take care. Do let me know in the comment section if you liked the session, and do let me know in the comment section how this session was for you. Was it a confidence booster for you? Okay, do let me know the honest reviews about this particular session so that I'll let all the other educators for physics and bio to carry out the similar sessions. How is my health? My health is not in a great, my throat is not in a great condition. I'm telling you that honestly. Okay, but I'm managing. I'm managing. I have to manage it only till 3rd May, right? After that, we'll see.